Thanks everyone. Thanks for joining. We are starting our SD-WAN sessions, SD-WAN classes, and today we are going to discuss about SD-WAN basics, their architecture and component. So let's start. Now we know that SD-WAN got evolved from where? From WAN. So earlier we have WAN, and now we have SD-WAN, that is software defined. So software defined WAN. Now if we want to check the differences between WAN and SD-WAN.
Hey, sorry guys, I get disconnected. I'm here.
Yeah, thanks. I already started the recording. So it just started within one minute back. All right, so let's discuss about basics of SD-WAN. We know that SD-WAN got evolved from WAN, and now we have SD-WAN. Now, if we go and check the design architecture of normal wide area network, we will see that different branches, so you may have different branches across the globe, and those different branches will get connected via WAN routers. So you may have your branch devices at different locations, and those different branches, those different headquarters, maybe you have one headquarter, you may have data centers, you may have other remote branches. All those branches will get connect via the WAN router. And now you may have different type of strategy within the branches to connect these WAN devices. That means you may have two routers in one branch. You may have single router, and then you may have two ISP link. So at the moment in this diagram, I'm not showing different types of branches, but assume that you may have two routers in a branch with two ISP link. You may have one router in a branch with one ISP link, right? The point here is this, that anyhow your remote users, once they want the default gateway, they will go and connect with the routers, right? So in between this, so here you can see this big circle, this orange type of circle. This circle is nothing but your service provider. So that means that you may have internet, you may have MPLS, you may have any other type of connection, maybe 4G, 5G, etc. So earlier also, we are talking about normal WAN, and then we'll go and check the SD-WAN. So earlier also, you may run your services over internet, MPLS, 4G, but mostly in the older design, you'll see that mostly people, they are running their services over MPLS circuits only, because the internet link was not that much great and reliable. So everyone, all the businesses, they are using the MPLS. Now, if you go and check today's trend, you will see that still people are using MPLS, but for other services within the network, if it is a enterprise network, for other services they are using internet as a backup link, or maybe internet as a active link. So we'll go and discuss about that change in the scenario. Or maybe at present, if you go and check the SD-WAN network, at present you will see that there are chances few services, they are 100% they are using internet. They are using 1 gig of internet line, or maybe 2 gig of internet line as a primary and secondary circuit. So uh, because of evolution of SD-WAN, we have this option that we can go and run our services over internet as well. Obviously, if you have internet, you need secure connectivity and all that we'll see later. Okay, so now this is a normal design related to WAN. So what changes we have if we go and use SD-WAN? That is one of the question we have. Now we know that when we are using SD-WAN, in that case, what we are doing, we know that all the routers, these routers, they have something called control plane. they have normal router, not SD-WAN routers. Normal routers also, at present, if you go and see, you will find that normal routers, they have control plane, management plane, and data plane, right? Normal routers, they have control plane, management plane, data plane. What is control plane? Whenever they are forming OSP or BGP or any protocol, whenever they are running any protocol that is under router core processing, that processing is happening via the control plane. If you are logging to the devices, so let me write as well. I'll write here. So any type of protocol when you're running, they are using, for example, OSPF, BGP, or STP. Suppose you are using in the switching network, or any type of routing protocol, or any type of protocol. Mostly they are using the control plane of a router. Then what about the management traffic? We know different type of management traffics will be there. What are those? So those are SSH, Telnet, SNMP, any other management traffic, like any other example, if you any telemetry example, if you have. Then data plane, actual data movement. Whenever actual data movement is happening via the router with help of routing protocols, where you have actual build of dynamic entries, such as adjacency tables, such as ARP cache, such as LFIB, LFIB. These things actually responsible for data movement, and here routers are responsible for data plane. Now in SD-WAN, what change we have? In SD-WAN, the change that we have, that we are decoupling the control and data plane. So what we are doing in SD-WAN is this, that at the moment I'll go and remove the management plane. So if you go here and see the router having control plane and a router having data plane. Now if you go to a router and if you move the control plane to some other cloud or to some other place, so all the routers, we are moving the control plane from the router. Here how many routers we have? Here we have 1, 2, 3, 4, 5, 6, 7 routers. So I move 7 control plane in one place, but these routers, they have the data plane. They are part of data plane. They have the data plane, and then we have moved the control plane in one place in a way that, and let me do one thing. Let me circle this. Let me change the color as well. Okay, this color is fine. Bring to send to back. So now with the control plane circle that we have, you have all the data plane devices. So all these data plane devices should have the connectivity, should have the control connectivity. We'll check later on about this, but these data plane devices should have the reachability to the controllers. These data plane devices should reach to the controller. They should go and reach to the controller. They are reaching to the controller. And at the moment, I haven't drawn any ISP in between, but either they are reaching via the MPLS circuit, or They are reaching via the internet circuit, but they have to reach to the control plane. So what will happen in this type of paradigm shift, in this type of arrangement, you will go and create the policies. That's the thing we have to understand. So now we can go and centrally manage, centrally we can go and manage the policies. Sorry for that. Centrally we can go and manage the policies. So what policies you can manage? You can go and manage the routing policy. What are the things you can go and do? You can go and manage the security policy. Then what are the things you can go and do? You can go and manage the IPsec key. You can go and manage the other things. I'll go and give you the other things, but at least these three things you can go and manage from the control plane: routing policy, security policy, IPsec key exchange. So what is happening, that from the controller you can go create the policy, and then you can go and push that policy to the devices. So now from the controller I will go and create the policy once, only one time, and then I can go and push the policy to all the data plane devices, to all the routers. So that means my operational overhead will get reduced. Why? Because I have to go to the controller and I have to go and create the policy once, and then I can go and push the policy to all the devices. So here I'll go and add one more overlapping circle below, and then this other circle I'll go and change the color for this circle is like a green type of circle we have, and this circle that you are seeing here, this circle is, think this as a management plane. So the circle that we have is the management plane, and from this management plane, which is integrated with the control plane, and then there we have one other component as well. But from this management plane, you can go and create the policy, and then you can push that policy to the control plane, and then control plane will go and push the policy to the data plane devices. So in that case, in terms of management, you can see that we are reducing the overall overhead related to configuration management, policy management, template management, compliance, and even monitoring and other operational tasks. Other operational task means image upgrade, downgrade, or rebooting the devices, running few commands from the from the management plane. So whatever task you have from your management plane, that you can go and manage from the management plane as well. Okay, so now you can see that we are doing the decoupling. What advantage we have with the decoupling? First of all, the advantage we have is this, that now you can manage everything centrally. The second advantage you have, that your operational overhead will reduce drastically. The third advantage, major advantage you have, that now this controller is independent of the data movement. So if your controller will go down, suppose all of your controllers are down, still there is no problem with the data plane devices, because these data plane devices, they already they have tunnel in between them. They have tunnel in between them. They have some sort of mesh type of tunnel in between them. All these data plane devices, they are running IPsec tunnel in between them, and that IPsec tunnel is fully meshed. Fully meshed IPsec tunnel is there in between them. That means if anything will happen with the controllers, is still these devices, because they have the IPsec tunnel in between them, that is the data plane tunnel in between them, there is no impact in the data forwarding if anything will happen with the controller. So this blue color is IPsec tunnel, that is the data plane tunnel that we have, and which is there everywhere in this blue color, irrespective of what ISP you are using, MPLS or internet. But these devices, they have IPsec tunnel going on, right? And then the connection that you are seeing from the data plane to the control plane is nothing but the, either it is TLS based or DTLS certificate based tunnel they have from the control plane to the data plane or within the controllers. So we are securing the connectivity from the controller to the data plane devices and within the control plane devices as well. And these things we will understand later on when we'll go and learn more and more and more about the concept. Okay. So far, you have any question?
No question. Everything good.
All right. So let's quickly go to the slide. We have some slides related to this. I will not spend much time on these slides. Slides. What happened to slides? Themes got stuck. Okay. No problem. So what you can do that you can go to our shared drive, and you can go to that location where we have the SD-WAN training folder, SD-WAN training. And here I have added one folder, CCNP SD-WAN docs. If you go there, then you will see 01A ABC of Viptela day 1. If you open that, why it is not opening? Okay. Yeah. If you open this, and let me maximize this. So we'll see that we have why we need SD-WAN, because we want cloud integration, reduction of MPLS cost, security, enhancement, API, means all sort of list of nice features we want. That's why we are using this. So this is little bit older slide, maybe 4 or 5 years back, few of the slides, not all. So at that time, we are discussing that, okay, what issues we have. So different branches running different protocols, different configuration, different type of integration. Some branches have some other requirements, some have some other requirement. It's very hard to unify all these requirements. So in that case, we need one central solution that will fulfill all the purposes. So that's why we have this centralizing the controllers. Like we'll see that controllers is vManage, vSmart, and vBond. So we are centralizing those controllers. So we need some sort of WAN solution, and that's why we have this SD-WAN solution. Now, at the moment, SDN based WAN was in the market. At the same time, we have different vendors with different solution, and all these vendors, they are good. So someone having some features, someone having some features, like that. And you will see that earlier, if you check the data sheet, you will find that in the earlier stages, this where it is, Silver Peak. In earlier stages, Silver Peak was doing really good. And why they are doing good? Because Silver Peak was a company, I think that is acquired by HP now or some other company. Silver Peak SD-WAN was very good because they have 10,000 plus application support. Still, you will see that Viptela or Cisco Cisco Viptela or VMware VeloCloud, they have only 3000 application support. But in the early days also, Silver Peak, they are supporting more than 10,000 applications. Application awareness for cloud, for WAN devices is one of the other feature that we want from the SD-WAN, that we'll discuss later on. How these devices, they are supporting the application visibility and all those things, we'll discuss later on. But you can see that the Silver Peak having this much of application support. Now you will see Versa. Yeah. So Versa is one of the fast selling SD-WAN. Then Silver Peak was number one for 2-3 years in SD-WAN. Now we have Fortinet SD-WAN also, which is doing good. I think Palo Alto also, they have their SD-WAN. So all major networking vendors, they have their SD-WAN. Either they have developed SD-WAN or they acquire some company. Cisco has acquired the company called Viptela, and again you can check the story of who is the founder of Viptela. So they work for Cisco for 20 years, and then they resigned. They started their own company, Viptela. They developed the SD-WAN solution, and then they have sold this maybe some $1 billion. They made this company as a $1 billion company. They sold this company, and then they started developing other product. That other product name is, I think, Avian Tricks. Something is there. Some cloud related uh, product is there. Avian Tricks or something is there. I'll search and I'll let you know. But that also, maybe Cisco will acquire that company also after 2-3 years with some billions of dollars. So those guys, what they are doing, they have, I think, 3 or 4 members in their group. They are developing. First of all, they are seeing that what problem these enterprises they are facing, and according to that, they are creating new design framework, and then they are hiring the software engineers and network engineers. They are creating their own product, and then they are selling to Cisco or any big players. So like that, they are developing some ideas. They are founders. Likewise, you will see this VeloCloud or other vendors. They may be very a small vendor, or maybe they have acquired some other other products and then rebranded, like Cisco Viptela. Cisco has acquired a company called Viptela, and then they rebranded this as a Cisco SD-WAN. That's the reason if you go and log into the VH devices, the Viptela earlier, Viptela devices were VH devices, and Cisco, you know that Cisco, they are supporting ISR routers, ASR routers. So that's the reason if you go and log into VS devices, you will see their configuration, like its configuration is like very much inspired from Cisco CLI. So those background things are there behind the scene, how they are acquiring the company, developing the product, thinking ahead, whatever there in the market, and then they are proposing the solution. Okay, so I will not go and spend much time on this. You can go and have a
At
look.
this time, who is the better?
Yeah, so I'll come to that answer, because I'm recording this session. Sometimes I'm uploading to YouTube these videos. So if I tell that, okay, VeloCloud is good and Versa is good, then Versa will come to me if they watch my video, and then they will tell, okay, prove my product is not good. So it will be difficult. So in that case, I will give you some answer that will satisfy. So answer is this: it depends. What type of what type of branches we have. So now you can see the key difference between this SD-WAN. You will see VeloCloud. I'll highlight here. This is, you can see, cloud delivered SD-WAN. VeloCloud is cloud delivered SD-WAN, means if you are using so much virtual branch, if you have too many virtual branches, if you want to integrate with cloud, if you want fast acceleration, application acceleration, then VeloCloud is number one. Then you will see Viptela. Viptela is what? Viptela is secure extensible network. Viptela is something SD-WAN plus SD-WAN security. This is not normal WAN. It has very nice integration with security product. Now, one disadvantage with Cisco product, always we have this disadvantage with Cisco product is this, that they are very much vendor specific. So if I want to integrate with other firewalls like Checkpoint, Palo Alto, these are very much locked. In that case, Cisco will tell, okay, use my FTD, use my container-based firewall, use my SD-WAN based firewall, etc., etc. But VeloCloud and other vendors, you can go and easily integrate with any firewall, even Cisco also. So that integration is, if you are using Cisco, use Cisco like that. Use all the Cisco product and all. So that is one of the weak point for Cisco at the moment, because all the companies nowadays, there is no company that they don't want to use one product or one vendor. They want to use different vendors, different products, because they have mix and mix mode of devices. So they want flexibility. They don't want their network to be locked with Cisco or VMware or like that. So that is one of the thing. And it's very interesting that you will find that there is one trend. So enterprise, what they are doing, they are using SD-WAN, Cisco SD-WAN for 3 years, and then they are telling, okay, let's use Versa for next 2 years. Let's use VeloCloud for next 1 year, because nowadays everything is very much subscription based. So if you are using virtual devices, more and more virtual devices, it will be very easy to migrate from one vendor to other vendor. Okay, so you can see now we have multi-cloud environment. Multi-cloud means that vendor is not going only to Azure. They are checking AWS. They are checking Google as well. Likewise, nowadays enterprises, they are looking for multi-vendor SD-WAN as well. So they don't want only Viptela or Versa. They want to use 2 or 3 vendors. Again, it depends from the higher management what they are thinking. So if you are looking for secure SD-WAN, go for Viptela. If you are looking for tight cloud integration, fast acceleration, go for VeloCloud. Then let's see Versa. Versa is also one of the nice SD-WAN we have. They have everything they have. And behind the scene, their market is also very good. So many vendors in India, outside India, in other countries, they are using Versa. Silver Peak, if we have good amount of application visibility, if you want those things, you can go and use Silver Peak. Then these are still on the way. People are using or not using these products. Riverbed is, that it is WAN optimization company. Then Telary is there. Because again, it depends upon budget and offering. And suppose if someone is using Juniper routers and switches, so for them it will be easy to go with Juniper product. So they can go and use Juniper. Juniper SD-WAN was very new. I think they also acquired some company, but nowadays they are doing good. Juniper is also doing good. So you can see it depends what vendor you want to choose. Is still uh, Viptela, VeloCloud. I think these two companies, if you go and see the Gartner report, you'll find that they are in top two. Either Viptela is number one, VeloCloud is number one, like that. So once you go and deploy these SD-WAN, then you are thinking, oh, which vendor support is good? Is Cisco TAC support is good, or VeloCloud support is good, or VMware support is good? So you'll find that uh, 10, 9 out of 10 people will tell you that Cisco TAC support is better than any other. So in terms of support also, means operational support also, you can go and put some marks that, okay, feature wise I am giving 10 marks, security wise I am giving 10 marks, support wise I am giving 20 marks. Then you can go and select one product. Okay, but you use VeloCloud or use Viptela or use Versa, all are very much, they are very good actually, and they are in the top 5 or maybe top 3. Okay, hope that gives your answer which one is best. Okay, so you have any other question? This is just for information. I will not spend much time here. Cisco, they are supporting inbuilt firewall. So if you go and check this list, you will see that inbuilt layer 7 firewall in Cisco, you'll find yes. Inbuilt IPS in Cisco, you will find yes. Cisco ISR. Let me highlight that. Cisco ISR, you can see here that they have all sort of security support. So if someone is looking for security support, they can go and use Cisco, right? Right. Again, some other what is SDN, why we are using SDN, and all those things. Already I have discussed in the whiteboard that use SDN. It has flexibility, integrations, API awareness, cloud integrations. You can centrally manage everything and all those things. In our previous session in DNA, we have discussed this slide that Cisco vision is to integrate SDA. You can see here. So let me go and mark the terms here. We'll understand. So you have your LAN devices. Remember in our SDA classes, LAN devices, where what type of rules you are defining to the devices? Edge, right? Then border, then CP, control plane. Now you will see here in the diagram that this particular device, which is part of SD-WAN branch edge. So your SD-WAN branch edge device can work as a SDA CP plus, it depends, CP plus border, right? So here you can see that this device that you have in the bottom, these devices, they are working, let me highlight that. So these devices, they are working as a, if you have tight integration in SDN and SD-WAN and ACI, they are working as a SD-WAN edge plus they are working as a SDA control plus border plane devices, where you can go and enable the, what protocol we have in SDA? Remember what protocol we are using? We are using Lisp and BGP, multi-protocol BGP and VXLAN. These things we are using in the SDA environment. And what protocol we are going to use within the SD-WAN, later on we'll study about that. In SD-WAN, we are going to learn the controller protocol is OMP, Overlay Management Protocol. We'll see that later on. Right, so these devices that you have, they can work. So here you can see that you have SDA fabric. Here you can see that you are integrating with data center. So now they can work as a normal branch edge devices. Here they can work as a branch edge plus control plane plus border plane for SDA, right? So if you have this multi-domain architecture, so in that case, you have traffic flow. That traffic flow will be something that these groups that you can see in the green, blue, and this orange color, they are actually different type of security tag, SG ACLs. So these ACLs, obviously, they are provided from ICE to DNA. They can reach to the SD-WAN devices. From SD-WAN devices, it can go to the cloud. Same tag will be preserved, and then it can go to the resources where you have servers and applications in the data center, and the return traffic with the same tagging. So one time you have to do tagging within your DC, WAN, and LAN, and that tag will be preserved throughout the fabric. This is one of the complex architecture that is still so many Cisco customers, they are using this. So Cisco is designing such type of architecture on behalf of customers, and customer, they are using this structure. If someone will go and use this structure, automatically their cost will get reduced, because in this case you are creating one routing table. Everything is part of one routing table. Obviously you have so many different VRFs. like a small routing table within one global routing table, but automatically cost will get reduced with this design and security will get enhanced because everything is glued in this architecture, in this multi-domain architecture, right? So that is the target you want to achieve, but there may be chances that you have integration in between SDA and SD-WAN, or there may be chances you have integration in between SD-WAN and ACI. So having all three integration, it may not be there with the customer that maybe that they want to achieve, but you can go and integrate one and two or three or one, etc., etc. So those integrations will be there. All right. So we are going to move to the um, next section where I'll go and explain the architecture and all. But if you have any question, please feel free to ask. Let me go and pause the recording. The usability of those devices and all. Let's continue that. So now in this diagram, you can see that we have SD-WAN component. This is actually the solution architecture. What are the components we have in SD-WAN? From your knowledge, you can tell me that. Have you worked on SD-WAN? So you know that what components we have in SD-WAN?
We have the
Yeah.
controllers and the routers.
Yeah. So what components we have? We have the data plane devices that may be V-Edge, Viptela Edge, or Cisco Edge, right? Then in the control plane, what devices we have? We have vManage, we have vSmart, and we have vBond, right? Now, if we go one by one, and if we go and see the use of these devices, so what is the use of vManage? This is there in the management plane. Here you can go and do all sort of configuration, template, policy, monitoring, integration with API, right? All these things you can do. Then you have vSmart, which is actually working as a control plane. So whatever routing decisions we have, whatever policy decision we have, everything you can do from vSmart. And then we have vBond, which is working as a first time authenticator. There is no much role with vBond. Actually, it is whenever a device, either controller device or a data plane device, they want to join the fabric or disjoin the fabric, they are doing with the they are doing authentication with vBond, which is working as a whitelist model. That means that the vBond having the serial number and chassis ID with the list that vBond have. So they have that list from vManage. Actually, vManage is sharing that information, the serial number, chassis ID, and all those things to vBond. And then whenever any device will join or disjoin the fabric, they have to do the authentication with vBond because they have this whitelist model, means they have the serial number, chassis ID. They are doing the authentication with the vBond, and then they are joining or disjoining the fabric. So these are the roles of the controllers. And then finally we have the V-Edge device. So what V-Edge or C-Edge device will do, that they are the data plane devices. They are getting the info from the controllers, and they are working, right? So it's like that. So very simple and straightforward rules they have. Now, later on, we have to go and discuss that how the architecture look like. So if I go and draw the architecture, let me go and show you this diagram. Suppose we have one diagram. So let's take the advantage of this diagram and let's try to understand the architecture. So here you will see that we have one data center and two branches. One of the data center having two VH, they are connected with two ISP. And then we have one type of branch where we have two devices connecting with single ISP. And then we have type 2 branch where we have one device which is connecting with two ISP. Actually, I think this diagram is a little bit wrong. It should be like this. So two devices, one link is going to MPLS, one is going to internet for high availability or redundancy, you can say. And then one branch we have this particular branch having connectivity with MPLS and internet like that. Now, if we go and draw the IPsec tunnel, so let me go and use the red color for IPsec tunnel. So IPsec tunnel will be there in between the devices. They will go and use the ISP link. You can see that we have IPsec tunnel or data plane tunnel like this, and then this, and then this. This is the data plane device like that. The other CS device will also go and form the IPsec tunnel with the other branch. So now you will see that this is full mesh type of connectivity IPsec tunnel. That doesn't mean that if the tunnel is active, if the tunnel is inactive and still we are using it, you will see that there is concept of active tunnel and backup tunnel, etc. That if tunnel is not active, this data plane tunnel is not active, then it will be in sleep mode. It will be in deactivated mode. We'll see that later on. Those options we have. If tunnel is not active, then why to use it? Because later on you will study that these tunnels, they are checking the liveliness. That means within these tunnels, they are sending some sort of BFD packets. So anyways, you have to go and check the liveliness of these tunnels. And if you are checking the liveliness of these tunnels, you have to go and use some sort of protocol. So BFD is getting used here in between these tunnels to check the liveliness of these tunnels, and to check this liveliness, you are sending BFD packets, right? So that means if even if the tunnel is not in use, you are not sending the data packets over these tunnels, but still you are sending the BFD packets, right? That means that is still you are utilizing some bandwidth. Why we are paying to MPLS or internet? To send and receive data, not to send the control packets, right? So those things we can discuss later on. Apart from that, we know that we have the controllers here. So for controller connection, let's go and draw the architecture in a way that I can show you the controller connectivity with some other color. So let me go and use the color green. So green color I'm using to reach to the controller. Again, they will use the ISP link to reach to the controller. So this is the, oops, not like this. Let me do it like that. Let me do one thing. Remove. So let's go here and let's use a green color only. So to reach to the controller also, obviously you will go via ISP, right? So over ISP, you are reaching to the control plane. And this green color that you are seeing here in the diagram, that green color is DTLS tunnel. Obviously, it is over ISP and then reaching there, over ISP and then reaching here. So two colors we are using here. One is the green color and other one is the red color. The red one is nothing but your IPsec tunnel. Later on, we will see that what keys and other parameters we have in this IPsec tunnel. And the green color that we have here, that is for DTLS or TLS connectivity, not in between the data plane and control plane devices, we have that, but within the controllers itself also they are using DTLS channel to do the communication. So if we go back to the architecture components and diagram, you will see that you can see here clearly that you have your data plane devices in below. The green color is the IPsec tunnel. Then they are connecting with different type of ISPs. Irrespective of ISP, they are reaching to the control plane devices with the DTLS tunnel. And then you have the control plane, management plane, and other plane devices, right? That is the architecture. The Viptela solution will provide you service chaining. This is very important topic. I will cover this in detail. Service chaining means that this question that you have asked earlier, that what is the role of firewall? Where is the firewall in this diagram? At the moment, not see any firewall here, but later on we'll go and enable firewall services within these devices. And if it is a data center or if it is a HQ headquarter, then obviously you need extra layer of security. So you can go and add extra firewalls there just behind these routers. So even I can go and use single arm firewall. I can go and connect one firewall here. So the traffic flow, once it will come to here, it will go to firewall. Firewall will inspect it. Then it will go to the core switch. The traffic flow will be like this. The traffic is coming from outside, for example. Then it is reaching here. Then it is redirecting to the firewall. Then from firewall, it will go to the core router. And from core router, it will go to the destination, right? The traffic flow will be like this. If my edge devices are working as a firewall, so the firewall inspection will happen inline. So the packet will hit to the router and then it will go to the inbuilt firewall and then it will go to the router. That we can discuss later on, how the traffic flow will be there if we have the firewalls in between that. But in um, in Viptela solution, in SD-WAN solution, we have one technology called service redirection. So anything that you are hitting here, you can redirect that traffic towards the firewall, and that firewall may be in DC1 or DC2. So redirect the service is very much like Cisco policy-based routing, PBR, redirecting the traffic in terms of that you are defining the next hop to the firewall, and then it will go to the firewall. Firewall will inspect that traffic and then it will go to the destination, right? There is pros and cons with this particular methodology that we can discuss later on, because once you are redirecting the traffic towards any firewall, then you should think about return traffic as well. So the policy that you will create, it should be bi-directional, and later on we'll discuss that the policy that we are creating in VSmart, if it is a control policy, it is unidirectional. If it is a data policy, then only it is bidirectional. So when we are talking about this service insertion, it should be somewhere. Anyways, this is service side of separate transport. This is actually different thing. But when we are talking about service insertion, then we have to think about bidirectional traffic. We'll check that later on. Now let's see the Viptela solution will provide you separate transport for separate VPN. You'll see that we have VPN 0, VPN 1, VPN 2, VPN 512, all those things are there. Centralized routing intelligence we have centralized, the network will go and secure itself automatically. Then we can go and manage everything from vmanage. We can go and create the central policy. We can go and easily integrate all the solution with the cloud. So all these integrations we have in the so all integrations we have, right? Then you can see this architecture. This is actually very big architecture that I will cover later. It will take 15 minutes to explain this diagram. But this is overall what is the goal we have with the SD-WAN. And you can see that this is divided in multiple layers, layer 1, layer 2, layer 3 and all. Okay, so this architecture I will explain you in the next class. Let me pause the recording.